allow me to introduce Atanu Roy, who's a principal deep learning architect at Amazon. In terms of his experience, he has worked across all the machine learning use cases, starting from recommendations, forecasting, fraud detection, NLP, and even predictive maintenance across domains like retail, FSI, healthcare, and even e-commerce. The session for today is more around uh, designing or hiring a good data science team, and then correlating it to the business use case. What are the pros, what are the cons, and some of the best practices that we can learn from Atanu's experience following the Q&A session. If there are any questions, feel free to drop in the chat window. And otherwise, Atanu would give some time to ask questions in between as well. With that, let me hand it over to Atanu. Atanu?
Hey, thanks, Pratik. All right, so hi everyone, thanks for joining, and welcome to this session of ML Elevate program. I understand that a number of folks from AWS partners and our ecosystem spoke to you in the past weeks on a variety of topics. So I hope you found them useful, and I hope that you find this session useful too. Pratik gave some background of me. I'll just add some more to it. I'm not going to repeat what Pratik already said. So I work as a senior science leader within Amazon ML Solutions Lab, and I lead the team for India. ML Solutions Lab in AWS is a global team of data scientists, applied scientists, research scientists, and we are chartered to help AWS customers solve their highest value business problems using machine learning. This is part of the AWS ML service organization. So we are the customer facing team of the ML service organization, which builds all the AI ML services and the platform services that you guys use forever. Pratik touched upon the kind of business problems that I worked on across domains, and on the science side, on the science domain side also, I got opportunity on working on quite a few science domains that are relevant these days. So that being said, coming to today's session, it's called Data Science First versus Business First. And the first reaction that I got from a senior data scientist in my team was like, how will you speak for more than 5 minutes on this topic? As in, what is the goal of a data science project or a data science powered product, other than working backwards from a business problem, understanding the domain nuances and solving it? On surface, it looks quite obvious as a topic to spend a lot of time on. But anyway, since we have to kill 1 hour anyway on this topic, I decided it might be more relatable to take a concrete hypothesis and try to disprove it. So this is the hypothesis that we'll prove wrong using 6 real-world examples from the last 3 years only. It is that a cutting-edge science team plus the right data equal to a successful data science project. This is what we will try to prove wrong. Now, I have given advantage to this hypothesis by giving it availability of sufficient data and the right data, right? Because by now it is established, and I think everybody knows that in order to make a data science project successful, you need the right data. Without that, you won't have good models. So that is kind of established now. So I don't want to keep that ambiguity in the hypothesis. So I'm already giving it the advantage that you have the data. So we'll look at examples, real world examples of what could be the potential reasons for failure in data science projects in spite of having a good science team and the right data. And we'll also touch upon the mitigation strategies. But before that, I looked up the internet to see if there is any content on this topic already, because I didn't want to waste your time by talking about something which you can already get on internet. I found this video. This is a YouTube video which I think which says building data science products, think business first. It's a useful watch, particularly if you are a early stage data scientist It talks about how to choose data horizon, how to make evaluation results more repeatable, how to interpret ML metrics in the context of the business problem. So it's a useful watch, and it targets primarily data scientists. And I think early stage data scientists would benefit by going through this video. So I would recommend for them. But I tried to broaden the perspective here a little so that it's relevant to product managers, product visionaries, and founders, in addition to data scientists. The examples that I'm going to talk through will widen the perspective a little. And at the end of it, I'll also try to share some of the best practices that we follow within ML Solutions Lab when we try to de-risk a project at the beginning of it. It's important for us that whatever projects that we are working on ends up in production. That's how we are measured as a team. So our leadership only, measures us if our work has ended up in production and running it for 1 year. So it's very crucial for us to de-risk a project at the beginning of it, so that we don't spend like 3 months of effort and eventually it doesn't end up in production or gets rolled back after going to production. So I'll try to give some of the best practices that we follow also. So here's the hypothesis again, and that will try to prove wrong. It's a cutting-edge science team plus the right data equal to a successful project. And let's start from the standard life cycle of a data science project that we are all familiar with. Understanding the goals, translating that to a machine learning problem, and then doing the usual dance of like collecting feature engineering, train, tune, evaluate to get a model which somebody is confident on. And then it goes to deployment and then online monitoring and a continuous monitoring kind of system. Now, in this life cycle, I think many of you will agree that this is the section of this life cycle that most of the energy and focus of the data science team goes in after the ML problem has been formulated. And the holy grail kind of this section is to get a model which generates good ML metrics on the right test data. So it could be like for a classification model, it could be precision recall F1. For if you're building a forecasting model, it could be MAPE or weighted MAPE. If you are solving a ranking problem, it could be NDCG. So the metrics could change. But as long as the metrics are giving good value, that's what is considered as a success of this phase of the overall project or as such. So let's look at 5 or 6 examples where, in spite of having good ML metrics, the project could fail. So the first one, again, these are all real projects, and I could have given name for many of these because many of the eventually successful ones are referenceable, but I mean, I'm going to share nuances of where things went wrong, where they went wrong, etc. So there are some sensitivity to it. That's why I'm not telling the name, but the first one is for a customer. Think of the largest payment gateway of India. Okay. The business problem is deduplicating user IDs from transactions using secondary parameters. Now, this is not a uncommon business problem for quite a few industries like FSI and telco and all. So there are situations quite often where, for various reasons, you could have 2 transactions for the same user having 2 different user IDs, and the reasons could be different depending on the source systems and the industry, etc. But I mean, just understand that there could be situations that 2 transactions belonging to the same user could have different user IDs. And in order to be able to target this user for downstream actioning, whatever be those actions, it's very important for the business to deduplicate those users or those transactions, to reconcile those transactions to a single user. So that's the business problem. Now, the circumstance in this case was they had a lot of data, 4 billion transactions they had when they came to us. They had millions of users. So no dearth of data. And theoretically, it was a very good use case for using graph neural nets, right? A particular paradigm called link prediction. If you're aware of GNNs, link prediction would have theoretically fit very well into this business problem. And my team was also quite excited because they got an opportunity to work on a cool problem. But after the exploration, what we found is, for multiple reasons, one is the depth of the user behavior projected in the data, and also the sanity of the secondary parameters. The secondary parameters would be users' other information, like say address, purchase pattern, phone number, bunch of other parameters based on which we are supposed to reconcile that, okay, these two user IDs are actually the same user, right? So because of the lack of depth in the user's behavioral projection in the data, as well as the sanity of the secondary parameters there, we could find that only 0.7% of the users could be targeted for reconciliation. So out of these millions of users that they have, only 0.7% could be targeted for reconciliation. So even if we build a perfectly good model, which is possible in this case, we would be able to target only 0.7% of their user base, of the ambiguous users. Now, if you look at the cost side of this project, it involves a graph database, a pretty large one too, because of the number of users and the richness of the feature set, etc. It would use graph neural networks, and there are cost complexities there as well. Now, that graph could not be a single graph because of the size. You have to shard the graphs, you have to time scale the graphs. So there is a non-complex cost complexity, there is a non-trivial cost complexity involved here. So we went back to the customer, with the data that, see, this is the cost complexity involved, and this is your targetable, reconcilable users. Do you think you have the ROI for this project? There were a bit of back and forth with the customer because they really wanted to solve this problem. But eventually, after looking at the fact, it was decided to abandon this project. So this is one example where you had the data, you could build a model which would have given good model metrics, but still this is not a viable project from a ROI standpoint, because the cost of the project would not justify the outcome that is going to come out of the project. Okay, let's move to the second one. There the customer is a leading online food company. You can think of the online app that you go to buy your pizzas. Okay, the business problem is to improve cross-sell of sides along with the pizzas. So imagine you go to the app and you buy a margarita pizza, and you get a recommendation that, this goes well with garlic bread and say a particular kind of shake. That's the cross-sell of the sides. Those are the sides that are being cross-sold to you along with your primary purchase, which is the margarita pizza. So the business problem is to improve the cross-sell, both in terms of volume as well as value, right? So that's the business problem. Now, what's the circumstance here? They had sufficient repeat buyers. When they came to us, they had sufficient repeat buyers to learn from. Now, this is an important thing, because in many cases we see that the percentage of repeat buyers are less, right? Which means that you end up recommending to most of your user base popular items, because you don't have enough history of those users to capture behavior from and personalize based on that. But in their case, they had repeat buyers. They had enough repeat buyers. And they had enough transactions to build a supervised model too. But the problem was, historically, only two sides have been offered to the customers: garlic bread and a particular shake. So if you build a supervised model on this data, that model would learn to recommend those two sites predominantly. It would do a very good job of recommending those two sites. Your model metrics would be very high, but it would still recommend those two sites predominantly. There are two, outcomes of this. There are two implications of this. One is that you have a bunch of other sites sitting there in your menu, which are becoming unexplored. And, the sale of those sites would be suppressed because you are not recommending those sites. That's one implication. The other is, this will not improve your cross-sell value or volume any significantly, because you are recommending the same sites which historically has already been given to the users. So whatever has been the reaction of the users to those recommendations would be consistent with what has happened in the past. So there is not going to be any significant lift to the cross-sell, which is essentially the business problem if you see. So this, when they came to us, this was the situation that is, and the cross-sell project was deemed as a failure. So we had to reformulate this as a reinforcement learning problem. Like, for folks who are not familiar, that would involve scientifically balancing the recommendations based on past behavior, as well as exploring new items, capturing feedback on those items from the customer, and using those feedbacks to define your recommendations, your future recommendations. So that would solve both these two problems. That actually solved both these two problems, both in terms of exploring new items on the menu, as well as increasing the overall volume of the cross sell. And we gave them knobs to play with the value also. So there were parameters that you could tune so that the recommendations are biased towards high value sites rather than low value sites. So if you want to bias your outcome towards high value sites as opposed to volume, you could do that as well. So it's a balance between the volume and the price. So this is a second example where you could have built a ML model which was perfect from a ML metric standpoint, but still it would have been deemed a failure from a business standpoint. That's the example that I gave when they came to us. Moving to the next one. This is an instance where the model is right by chance. And such projects would fail during the user acceptance test. Now, this customer is a large global investment bank. And the business problem was explainability of email classification models. So they have millions of emails, and they have a classifier which is trained to identify whether an email is a market manipulation email or not. That classifier has been trained on a bunch of data, tested well, and the ML metrics are very good, right? So it is telling a market manipulation email as a market manipulation email and vice versa. But what the SMEs, as in the auditors, wanted is that give me explanation to this model, to the model outcomes. Now, model explainability is a wider area, so I don't want to go there, but just in the context of this use case particularly, just think of this as the first example where this is the text which says investments are not disclosed, don't report her abuse. This is a text. The explainer, the so-called explainer model, will tell which are the tokens or words or phrases based on which the model has said that this is a market manipulation text, right? So for this text, you can see that 1 versus 1 on the right means that the model predicted it to be 1, which is a market manipulation, and the actual level was also 1. So it's a correct prediction by the model. And then in the next line, you get the top 5 tokens which have been detected by the explainer, which it understands that these are the tokens based on which that the model has made this prediction. And the tokens are don't, investments, disclosed, abuse, are. But when this has been reviewed by the SME, The SME rationale is not exactly what the explainer has said. The SME thinks that report her and abuse are the two keywords based on which the SME considers this to be a market manipulation. In the second example, you can see it's a little longer example. According to some company's managing director, the project will stabilize costs and improve supply security. It will use the proceeds for the transaction to achieve its target. Do it for me and will help you get paid. So this is clearly a market manipulation conversation. And the model has done right again. But again, if you see, the explainer is saying that the model has called this a market manipulation because of the presence of these tokens. Paid transaction will do improve. But the SME says, do it for me. This is the phrase because of which the SME thinks this is a market manipulation. So this project was a failure because the audit team said that your models are predicting randomly just by chance. So it's just chance that it was trained on a data where males having this kind of tokens were positive males. And it has learned to pick up these tokens and correlate with them with the market manipulation. Right? So the classifier was unacceptable. The mitigation to that we introduced was, as part of the evaluation strategy, in addition to the classifier evaluation, which was already happening, we evaluated the explanations also. So first we generated explanations for every classification, and we evaluated the explanations on SME annotated explanations. So we asked the SMEs to annotate the explanations of all the training test data, as in to tell that, which are the important phrases or tokens that they think is causing this particular outcome of market manipulation or not. And in addition to the classifier metric, we computed metric of the explanations also based on those annotations. The metrics would be different. For the classifier, it's a F1 score metric. For the explainer, the metrics are IOU or coverage. So they are different. But in the tuning process, both the classifier metric as well as the explainer metrics were considered. And a model which was trained using both these two criteria learned not only to be correct in the classification, but also to be correct because of the right reasons. Right? So that's how the overall solution moved from, a UAT failure to acceptable solution. So I'll take a pause here. 3 examples I shared. Before I share any more example, if you have any questions or if you're struggling to follow, I can take questions, a few questions now.
Hi, I had a question. This is Avi. I'm the CTO of Amicus AI. In the last example that you were talking about, were they like a 2-stage model is what you were using to solve such a problem? Or like after the potential causes had been reviewed by the SMEs, after that, I'm asking.
Yeah, the pipeline had 2 models. First, there was the classifier and then there was the explainer. So the event pipeline had these 2 models in sequence.
Okay. And I just wanted to get the the thought process behind that, because my experience with 2-stage models has been because the accuracy of the first model has to be very, very good for the accuracy of the second model, for the second model to be accurate. So was there any discussion? Did you went to a stage where you were doing parallel models and they were not working out, and that's why you went for a 2-stage model?
The accuracy of the model was on the start itself was like a 95% F1 with a recall of 98%. So it was pretty high. So we had that to make it a sequential pipeline.
Okay. Thank you.
So we'll move to the next example, which is again for a online food company, a different one. The business problem is personalized menu ranking. So you can think of these food apps that you go to order stuff, and in the launch page, you get the menu listing. So the use case is to personalize those listing based on who is logging in. So I would get a different listing than you, and even the ranking would be different. The ordering would be different. So that's the problem. The circumstances, the model which we built, in fact, had a very high precision recall at K. PR at K is again a standard ML metric for ranking problem in addition to NDCG. So our model produced a very high PR at K at offline test. But when it was deployed for A/B testing, we were continuously getting feedback from customer that we are not getting any boost. For 1 month, 2 months, they kept reporting that they're not getting any boost, which was counterintuitive to us, because based on the benchmarks that we did, we were pretty confident about. With some customers, we participate in the A/B strategy, and with some customers, we don't. The customers do it themselves. So here we were not involved in the planning stage. So we looked at the strategy that they are following, both from a user split as well as the way they're measuring the A/B results. And we found that in addition to our recommended top N items, so we were only, they might be having say 50 items. We were only recommending the top 10, right? Because those are the 10 which come in one screen. So when you go to the listing page, probably you get 10 items, right? So those are the 10 items that we want to be more accurate on, because we don't want you to scroll down too much to find your item. And that's how we want to enhance your user experience as well as drive more business. So in addition to our recommended top N items, customers was tracking conversion of all the displayed items, as in all the 50 items. So the aggregate metric, the aggregate business metric in terms of conversion was quite oscillating. So it was increasing, sometimes going down, sometimes it was pretty unstable, because they were aggregating everything together, even beyond the top 5, top 7 that we recommended. So once we fixed this, once we found this out, then we spoke to their A/B team and got this fixed the way they were measuring the outcomes. And from the 3rd month onwards, we observed steady lifts. So the 3rd month was small lift, but then 4th, 5th, 6th month onwards, they got a progressive lift into their conversions. So the takeaway from this example is, look at the A/B testing strategy also. We have been in situations where the user split has not been right between A and B. And that has resulted in, misleading results of the A/B test, which again goes back to, deeming a project as failure. So even beyond your offline testing, the A/B testing strategy as well as the outcome measurement is quite important. So we need to see it through rather than just finishing at the ML metric. The next example that I have is for, a leading general insurance provider in India. They have various different insurances like health insurances, car insurance, other life insurance, different kinds of insurance. And here also they want to increase the cross-sell of the insurance product. As in, if you have bought a particular product, they want to sell a different product, a different insurance product to you in a informed way. They built a cross-sell model, which was again having a good ML metric, but it was not yielding any business benefit. No increase in cross-sell volume when they were actually using that model in production. That was not increasing their cross-sell volume in the business. We revisited their overall strategy and overall pipeline. One is they are telling there are, say, 1 million customers, right? And you have who are going to call these customers to actually sell the products or offer the products. Now they don't have the capacity to call all 1 million customers. So they do some random sampling. And the model gave them, say, recommendations for all the customers. And they only called a subset of those customers. And you don't know whether the customer that you called had higher chance of accepting this recommendation than the customer that you did not call. right? Although the recommendations are working well on the test data that they have considered, but because you are not exposing the model to all the customers, you are getting half-baked picture. So it results in two things. If you are not calling the right customer, you are destroying the customer's experience, and you are also wasting a lot of agents' time, because you have not given them a curated list of customers to call with the recommendations. So the mitigation to this was we put a user propensity model first ahead of the recommendation. So the purpose of this model is to just score the user propensity, which means that how likely is this user to buy another product, even before recommending which is the right product for this user. Just find what is the propensity of this user to accept a recommendation. And once you do that, we ask the agents to call with the recommendations only the top decile of the propensity model. So the propensity model output scored all the users based on their propensity score, and then we created deciles from them and asked the users to call only the top 2 deciles. Right. So eventually, this is again a referenceable use case. This is, I mean, you can look up in internet. This for Edelweiss, there is a blog also for that. So they eventually got a 300% increase in cross sell, with 98% of those happening from the top deciles. So again, you originally at the start, you had a recommendation model. They had a recommendation model which had good metric, but it was not yielding business results because the business dynamics were not fully understood and absorbed in the solution pipeline. The last example that I'm going to talk about are NFR related, as in non-functional requirement related failures. And this is again quite common. This is something that we evaluate pretty early on, because the more heavy feature engineering that is needed in the pipeline, the barrier to low latency inferences are quite high. And most of these NFR related failures are for online inferences, as in where you are inferring a model in real time or a near real time. So we have to be mindful when we are designing the pipeline that how much feature engineering we can afford to expose at inference time to meet the response time requirement that the customer has. Alternatively, can the architecture that the customer already has support a bunch of engineered features? And if they are caching a bunch of engineered features, then they have to also make adjustments for updating those features and synchronizing it offline. So is the existing architecture that the customer has can support these if I am needing heavy feature engineering? So that's something we need to decide upfront. Otherwise, we can build a very sophisticated, well-performant model on a lot of engineered features and then discover that the architecture doesn't support. So they won't be, their data team won't be able to, integrate this model into the pipeline. Similarly, whether the model needs non-trivial post-processing involving additional database lookups, etc. What is the impact of that on the end-to-end SLAs that they have? If you are using deep learning based models, do you need a GPU to infer that model, depending on the size of the model and the connections in the model? If yes, then is the customer ready to pay for a GPU? Do you have a scale down option of using something like, say, Inferentia, that one of the offerings that we have, which have sharded GPUs? So you have to discuss those things before you finalize what is going to be the approach, whether I'm going to use this very heavy, large, deep neural net model. And of course, you have to be aware whether you are building a model and who will maintain it. So is there enough talent or vendor support ecosystem to monitor, maintain, and enhance a very complex model that you have built to solve a problem? So you have to also think about the mid to long term. These are the NFR related considerations that that are recommended to be gone through before you actually decide on the modeling approach. Now, before going to some of the steps that we generally follow to try to de-risk, and again, you cannot 100% de-risk a project. There is always some risk involved, but it's a best effort thing. So these are some thumb rules that we follow.
So the question here is, they already had a model, right, which was they deployed, and they had, let's say, whatever agents they had. So were they able to consume all the customer queries? And that was failing because then this does not follow through. But if they already had a model and you suggested another propensity first model, right? So either they decrease the number of agents post this, then this makes more sense. You understood the problem?
Yeah, I understood. I think I understood. Correct me if I'm wrong. So the problem was that their agent to call ratio was not, like, the target user ratio was skewed, right? So they did not have enough agents to call all the users. So with their existing model, they used to get the recommendations for all users, but then they used to sample the number of users that they would call. So roughly imagine they would call 30% of the users that they have. That's a scale issue. Now compare that situation with the propensity model, which is telling them that these are the 30% users that you should call. So they are still calling.
I'm just just figuring out, if they had a model, isn't propensity first the basic model for every? I mean,
It was
even
not.
without,
Yeah,
okay.
you would be surprised. It is, I mean, I would say in the last 8 months that I've had conversations on similar use cases, everybody understands that propensity first is like a de facto, but it was not the case when we solved this problem. There were customers who were doing recommendation without propensity.
Okay, but the problem with propensity is you've got to have a full subset of previous history for propensity to work.
Yeah. It worked pretty well for them.
All right, thanks.
Yeah, right. In the last, we have worked on 3 more, I think, cross-sell for telco customers and retail customers, where when the customer came to us, they knew that they would need a propensity first. So I think the awareness has increased, but Edelweiss was a couple of years back. So
yeah. So and this is counterproductive to the pizza and the sides example that you gave.
Yeah.
So both of them are like opposites, right? This
Correct.
recommendation is
So there
opposite
you
to
don't,
that.
right. So there you don't have the problem of agent versus user, right? There it's a recommendation that is going online. So every user is getting a recommendation. So here the problem is that you are downsampling the users that you are actually offering to. So you don't know which are the users that you are leaving out and not calling.
Yeah.
Right. So the two situations are different.
Yeah. All right, thanks.
So I just wanted to understand, and maybe coming from the healthcare industry. Assuming if the model was deployed, and what is the periodicity and frequency to monitor? I'm coming from like 6 months, 12 months down the line. So do you keep monitoring that? Are there any industry benchmark? Because if there is a performance decline, you have deployed it once, and how often are these monitored?
Yeah, so that's a very good question, and I think that could be a topic of like a 30-minute talk. What we have in our experience found is the online monitoring strategy, which is what you're talking about, has a lot of dependency on the particular use case, not even to the vertical, to the industry. Even within a single industry, there could be different use cases having different monitoring needs. So it would be a little superficial for me to have a single strategy, but there are a few strategies which we generally play around with in terms of monitoring and then actioning. Some of it requires some architecture handling as well, as in you need to do some additional architecting on the downstream side so that the online monitor results are feeding back and triggering a retraining cycle and kind of automating this loop. So the last is some of the thumb rules. And again, these are by no means are like the exact ones that are going to work for you. You might have your best practices. This is just what we follow. So whenever a problem comes to us, we start with something called a diagnostic call. The purpose of the diagnostic call is more of sanity, just to see whether the customer even understands the use case, the nuances of the use case. What do they have in mind of how are they going to know that this use case is working or not after it is solved? Do they have the data, where the environment is going to be, how big the data is or how much back in the history they have the data from? So these are more of sanity calls. For a product company, this would only be relevant when this is happening between the data science team and the product team within the same company. So when the product manager comes to the data science team that, hey, these are the new features that we are building, it might be useful for the data science team to, have a diagnostic discussion before spending too much bandwidth into a detailed discovery. So that's what we do. Second step is the discovery step that we call. It starts with data familiarity, where we actually look at the data. Very crucially, we spend a lot of time on this one, is the business metric identification. And we make it mandatory that the business stakeholders of the customer are in the mix, because in most cases, our counterparts within the customer are their data science teams or the data analytics team. But we make it mandatory that the eventual business stakeholders are in the loop and they are participating in the discovery workshops, and they share the business metrics with us, that how are they going to eventually measure the business outcome. And business metrics could be like primary, secondary, and there could be guardrail metrics for, like, I'm sure you know, but just like in case anybody is not aware. So take an example of, since we are sticking to personalization, let's take personalization only. The primary metric for a personalized recommendation would be, or say, imagine you are personalizing the user interface and giving them certain buttons or certain flags based on a user's preference. So the primary metric would be the CTR on that button or flag, whatever you have given. So how many clicks are happening on that particular thing that you have given? That's the primary metric, increase in CTR on that. The secondary metric here would be decrease in clicks on the other flags on the same screen which you have not recommended. Okay, so imagine, I'll give you a concrete example of user reviews, right? All these websites that you go, say, Make My Trip, Zomato, all these websites, they are all our customers, by the way. You have these reviews, and then there are personalized reviews, like on the top of the screen, like flags that you would click and they would take you to that particular kind of reviews. And then there are wildcard reviews, as in click on more or all other reviews, this kind of thing. So in this, if you are personalizing those flags at the top of the review screen, then the primary metric would be the increase in CTR on the recommended flags, and the secondary metric would be the decrease in CTR on the wildcard flag, which is like all other options or click more or those kind of stuff. And the guardrail metric obviously would be the increase in conversion. Increase in conversion as in the dollar value of the business. That is like a guardrail metric, although that is not directly dependent on this particular use case that I'm talking about. But still, customers keep a guardrail metric they understand that the guardrail metric increases much less than the primary metric. So the objective of my project is to increase the primary metric, the maximum, and not decrease the guardrail metric. Provide some kind of lift to the guardrail metric. So that's how a business metric is formulated when you are in the early stage, when you are talking to the business folks. And then based on the identification of the business metric, you mutually agree on the success criteria. Like, what is the lift in CTR that is good enough, right? And that is done basically based on baselines. So in most of the problems, for us, a little different from product companies, but for us, in most of the problems, we have baselines, because even if that's the first model that the customer is building, they have business baselines, because they would have solved that problem in some way or the other. I mean, they would have tried to solve that problem using heuristics, or using business logic, or using like people with their intelligence, with their business intelligence, they are making decisions. So whichever way the decision was coming, but the baseline business metric would still be there. So we would use that as a baseline, and then agree on a percentage lift on top of that baseline through our solution. In case of product companies, which is like starting a product, you could look at industry baselines for similar products or similar industry. There have been one or two cases where we have worked where there was no existing industry baseline also. Those are tricky cases to, brainstorm and find out what is the right business metric, and maybe try out a little bit variety of business metrics during online testing also. But that's generally what we follow in terms of success criteria. And then again, as I gave you a couple of examples, we also focus on the evaluation strategy, both offline and online. How they are going to do the online testing, what are they going to measure, how are they going to split the data, which are the control set of users that they're going to use for the online testing. Those are the things that we pay attention to. And finally, deployment readiness. This goes back to the NFR related failures that we are talking about. So we look at, what are the integration requirements? What other systems within their environment do we need to integrate to? Are those teams aligned? Are the integration, how complex are the integration? Would that team also spend bandwidth to do the integration work on their end? So those are the things also that we evaluate in terms of deployment readiness, even before we start looking at the approach. And then after the discovery phase, we go into the approach phase, where we do a feasibility study. This is the ROI study that we do. I gave the first example around that. And then we start thinking about modeling techniques and how would the pipeline look like. So all the data science, pure data science work actually starts after this. So these are just some of the things, and we keep evolving this as we learn from mistakes also. So some of the steps that we follow for de-risking projects. That's all that I had. I think we have done very good on time. So if there are any last questions before we close, I would be happy to answer.
Hi, this is Avi again. One thing I wanted to understand was how do you account for inference time in your business metrics? Do you have like separate set of business metrics? Like how do you basically, I've asked this question previously in other calls as well, and something we are dealing with right now. But how do you balance accuracy and inference time? That is, as a business metric, is what I want to understand.
In most cases, in my experience, they have come from the same stakeholders. Okay. But there are situations where it could come from two different stakeholders also. That's when it becomes a little difficult. But if it is coming from the same stakeholder, then they strike the right balance, right? Generally, I have seen them say on a 80 millisecond, imagine we have built pipelines which had 80 millisecond response time requirements, right? They would be willing to, increase the response time by say 10% in order to accomplish the accuracy. But there is obviously a guardrail for the response time that they can go. There is something that they won't go beyond, but between accuracy and response time, they generally lean towards accuracy as long as the response time guardrail is maintained.
Okay. And this communication has to be handled by us. Like, is there a standard way that you explain the trade-off to this trade-off to the two parties? If there are two separate parties that have different requirements, like in our case, the accuracy is coming from a different stakeholder, but the inference time requirement is coming from a different stakeholder.
Yeah. So, I mean, these are, there is no formula for this. These are discussions and, convincing that needs to happen. Generally, what we use is we talk through past experiences, right? Rather than talking theoretically, we give them experiences that, hey, this is a similar customer like yours for whom we did this and it worked for them. or this is where it has not worked. 100 millisecond is something, if you are targeting 80 millisecond, 100 millisecond is something that we have seen your customer traffic don't drop. Your customers don't go away because it increased from 80 millisecond to 100 millisecond. If it goes to say 500 millisecond, there would be a drop. So you put your guardrail metric to 100 millisecond and let's bias towards accuracy. So these are ongoing discussions that you need to have, but they listen if you talk through past experiences.
Okay, great. And comparing it to, does it make sense to, like, in your experience, does it make sense to compare it to the present time it's taking to to be able to do the same activity?
Absolutely, yeah. So some baseline. I was talking about baseline, which is past work. If you're talking about the baseline as the present, if they already have something which is meeting 100 millisecond and they are expecting something which is a higher accuracy but to meet 80 millisecond, that's not a logical ask, and that's obviously a valid point that you can discuss through.
Okay, great. Thank you.
Sure. Thank you, everyone. Thanks for joining again, and hope you have a good day.